Hello guys, welcome back to another video. In this video we will prove this equality from 0 to 1 minus ln of x to the power of p over 1 minus x dx equals to gamma of p plus 1 sum running from k equals 1 to infinity of 1 over k to the p plus 1 for p greater than 0. Alright, so how will we do this? We will introduce a substitution, negative ln x equals, for example, I don't know, y. Alright, so when we do this, we get when we do the derivative on the both sides, we got minus 1 over x dx equals to dy dx equals to negative x dy. This is what we get. So, and we need to solve for x. So here we get ln of x equals to negative y, x equals to e to the negative y. So this actually turns out to be negative e to the negative y. Okay, let me write this y a bit better. Y dy. Alright, and the boundaries. Alright, so when we put 0 here, when we put 0, we will get negative infinity, but this minus will turn this into positive infinity, and 1 is just 0. So we will have from infinity to 0, but we will use this minus to flip up the boundaries. So let's continue here. We will have an integral from 0 to infinity. What? We just have u to the p over 1 minus, we have e to the u du. Wait, am I correct? Negative u. Yeah, negative u, because we got it from here. And divided by 1 minus, and what's x? X is negative u, e to the negative u. Okay, this is what we have. Okay, let me write this a bit better. Negative u. Right, what will we do now? You are probably asking yourself what to do now. I mean, me too when I first tackled this problem. But we will expand the numerator in a summation form. What do you mean by that? I mean, we will write it in a binomial form. You know, alpha over n, x to the n, and so on, for n greater than 0, and so on. So we will use this here. I will show you how. I won't show the entire procedure because it will take too long, but I will write this 1 minus e to the negative u to the negative 1. When we put this in a summation, we will get some minus 1 to the power of n. We will have minus 1 times minus 1, and so on. We will have minus 1 to the n factorial divided by n factorial. It will get cancelled out and we will have just this. And now times x to the n. X is here negative e to the negative u. So we have negative e to the negative u to the power of n. Alright, n goes from 0 to infinity. Alright, what happens here with minus 1 to the n? We can take in the front and it will cancel out with negative 1 to the n. So we'll just have e to the negative yn. So we will have this e to the negative yn, and so we will put this back into here instead of this. So you get what I mean. E to the negative un. This equals an integral from 0 to infinity y to the p e to the negative yn times e to the negative y dy. Let me erase this. I will need space. It's not yet over. And of course we need a summation, but I am e to the negative un times negative u. Okay, summation e to the negative un times e to the negative u, and n goes from 0 to infinity. Alright, so what will we do now? We will combine these two, and we can take the summation in the front. We can take the summation and integral u to the p e to the negative un minus minus u du. And what we will do now, this looks kind of like a gamma function. We will introduce a substitution, negative un minus u equals to some k, for example. Not k, we have k there. Let's use, I don't know, z, negative z, because we want the negative there for the gamma function. And now what we do now, we will differentiate this. We get negative n minus 1 negative z dy dz here, dz, and we have dy equals to dz over n plus 1. Okay, let me take this out of the way. Yeah, like this, and we have what we need. We need this one, and so we can plug this back in. We have what is dy, but we need y. We need this in terms of y. Okay, so let me see. We can take negative y in the front, n plus 1 equals negative z, and now we can solve for y. We can multiply both sides by negative 1. We get y equals to z over n plus 1. All right, this is what we get, and now we will, of course, then goes from, yeah, something like this, and now we go back here. When we put 0, we get 0, but when we put infinity, we get, this is negative infinity, and this minus z will give us positive infinity. So we will have an integral from 0 to infinity, u to the p, u is z over n plus 1. It will be z to the p over n plus 1 to the p. But from the dy, we have n plus 1. So we will have z, not z, yeah, z to the p over n plus 1 to the p plus 1. When we will also have a summation. Yeah, I missed out the summation sign. We need the summation. We have this, and yeah, we took this into consideration and this, and now we just have to put e to the negative z. Yeah. As you see, this is a different part. This is a bit messy, but I think you know what I'm doing. Okay. Now let's take this in the front, since it is a constant dz. We will have a sum running from n equals from n greater or equal than 0, but let me write it a bit better so you know what I mean. 1 over n plus 1 to the p plus 1. And what is left out? Okay, let me erase this part. We really don't need it anymore. We have an integral from 0 to infinity, z to the p e negative z dz. Okay, I have done this integral many times in the past in my video, so I won't use a lot of time for this. This is a gamma function of gamma of p plus 1. A gamma of p plus 1. This is a gamma function of this. So let me erase this. Times gamma of p plus 1. This is independent of the sum. And so this looks similar to this. Yeah, but there is a problem. There is k and there is p. So we can just introduce a substitution here. N plus 1 equals k. N plus 1 equals k. And so this equals sum running from k equals 1 to infinity, 1 over k to the p plus 1 times gamma of p plus 1. And therefore it is proved. It is proved. I hope you guys enjoyed this video. It was a bit messy. I mean, we started here, we implemented here and there, and so on. There is a substitution. I mean, from here, here. A lot of things are going on, but I hope you guys understand what I'm doing. That was it for this video. Like, share, and subscribe if you want to see more of this. And see you in the next video. Bye, guys.